So things to remember from this. One, how forever is this? Think about the fact that you get a mortgage on a house, your bank is carrying that for 30 years, plus they have to have 7 years after that for tax reasons, so they have to keep that data for a minimum of almost 40 years. They may need it longer than that for certain legal reasons. So when you go out and you build some sort of a model that says here's a table and it relates to this other table over here where we've got multiple rows in this table and stuff like that, you're really making a model that for data that's going to have to be around probably as long as you're going to be working in the computer field. It doesn't go away. Now, that means that database systems like Oracle, MySQL, Postgres have to maintain data and be able to be updated forever into the future. They don't go away either. 2, people don't migrate. If you make a choice to use Oracle today, the product that you're building is going to be using Oracle if it's around 20 years from now. Migration just doesn't happen very often. If a business is committed to using one kind of a database, that's the one they're going to use. So these things are also very long term. And yes, SQL is a standard and you can figure out how to use multiple databases, but actually porting data between systems does not happen very often. These systems tend to be hard to test. I did a bunch of work for phone companies, and for instance, we might want to set up and run a test on a new customer service system that has to interact with various pieces of customer data, from their account records to where their billing is, to who they are, to whether or not they got married. Did they combine accounts? Okay. Did they, at that point in time, own 5 7-Elevens and they bought a 6th from somebody else, and now that's part of that account? This is the kind of stuff that gets hard to track, but now you're talking about a huge amount of data. So you might have, a database with 15 gigabytes of data, and you need to make a copy of that because the developers and the testers can't test on the production system, so you've got to make a copy of that, and you need multiple copies of that, and, this starts to become very difficult. And suppose that a developer mucks up and breaks the data here, they need to be able to restore their test copy, because, there was something wrong in their code, and they were actually testing and being productive, and they found a problem. That's a successful test. Well, it's successful right until you go, you can have new data in 2 days. Okay? That kind of a thing. And then they want a refresh of their data from production. And suddenly, this starts looking like this stuff is hard to test. Okay? We're going to come back to this in the next lecture in much more detail about why it's hard to test and what the ramifications of that are. But yeah. And the 4th thing is that long-term maintenance is key. That's why a database has to have all of these alter commands to allow you to modify an existing data model, because the data is forever. And if you want to build a new application and you have to have, user accounts, and now they have to have an expiration date, so that you can beforehand turn the count off so that at a certain date and time it expires and ceases to exist, but there's no expiration field, you got to be able to add that to your table in one fashion or another. Backups and restore. Those turn out to be critically important items. So out of all of this permanence and this difficulty in managing and testing it, there's a lot of jobs. There are going to continue to be a lot of jobs in the field of basically administering this as a database administrator. And DBAs tend to get paid pretty well. A experienced DBA in the land of Oracle these days is making about $150K. Certainly, if you're more specialized and you just work on things like performance tuning, it's not unreasonable to charge people for short-term contracts to come in and work on things for, $2,000 to $4,000 a day for this kind of specialized work. But yeah, that's decent, and that's not out of the reach of somebody that wants to work at this and make certain that they know all the different things, get some certifications or get some practice where you can actually explain to people this is what you do and this is how you do it and be confident about it. Those are reasonable kinds of numbers to be expecting for an experienced database person. Now, in our stack of the world, we have, a user out here with a keyboard that's talking through a bunch of servers and a cloud down here to an application server, down here to a database. Okay? And the information is going back. We've talked a little bit about full stack, but this all full stack stuff also requires that you have knowledge about a database and how you're going to use it and what you're going to do with it. And in this process going up and down with full stack stuff, you also have to have application server knowledge and networking knowledge and front-end knowledge and cascading style sheets, but database is a big part of that. And what you can do and get it to work full-time as a database is a big thing. And again, there's always demand for people to do full stack stuff because there are lots of small businesses that don't need a full-time DBA for their stuff, but they want to build an application. And even large companies. I know a person who works here remotely in Laramie. He has had 4 different contracts now with Pepsi to do different kinds of applications for Pepsi. He makes way more than this because he works as a contract worker, multiply that by 2 a year, but all of the stuff that he does is full stack. So there are people around making good money, doing about 1/3 database, but they're doing these other pieces as well, and they're good at it. So the future of database looks bright. There are lots of things going on, but the big thing I can say about database is that it's going to be around for a long time because, yes, the data is permanent. It's persistent.